I know it's been quite a while since I last talked about automation topics here on this channel, because I'm still pretty busy with my home lab and server projects. However, let's mix the topics from time to time and not just focus on one particular thing, because I'm really excited about DevOps and automation. I think that's somehow the future of IT. And since I started to learn more about container orchestration in Terraform, I thought why not combine these topics and learn how to automate Kubernetes. So in this video I will show you how to deploy a whole Kubernetes cluster fully automatic with Terraform. We create a high available cluster in the cloud. We deploy a load balancer with Traefik and a small web application on it. The project also includes SSL certificates managed via Cert-Manager and a public DNS record, so everything is fully automatic and it will be up and running in just a few minutes. So if that doesn't sound interesting to you, I don't know what you're doing here. One thing I want to say before we start. So in this video I will use many tools and programs that I've already shown in previous videos, like Terraform, Traefik or the Cert-Manager. And I can't cover them all in detail here. If you'd like to have a more in-depth explanation of one of these components, I've done separate videos on probably all of them, and I will link them in the description, so just check them out if you want to learn more. And if you still have any questions, you can always join our Discord community for help. This is, by the way, a great idea anyway. But I still want to give you a quick overview of what we're doing today and how these tools work together in this project. The primary tool that we're using in this video is Terraform. And Terraform is a free and open source infrastructure as code automation tool running on my workstation, and it's responsible for creating and managing these resources. In a previous video, I've shown you where I've used it to deploy a Linux server and some Docker containers, but today we go a whole step further and use Terraform to deploy all the resources we need for this project. The first is our Kubernetes cluster, which is running in the cloud. And if you're watching this video, I guess you already know what Kubernetes is. That's our container orchestration where all the workloads are running. But Terraform will also deploy everything else. So for example, once it has created this Kubernetes cluster, we use it to deploy an Nginx web server on it, just to demonstrate how you can automate any kind of web application on the cluster. And because we want to publish this on the public internet, I will deploy two more applications on Kubernetes to help us doing this. So one is Traefik, and this is a central load balancer and will get a public IP address from the cloud provider and route any incoming traffic to the web application with an ingress object. And this ingress object should also get a valid SSL certificate that I'm managing with Cert-Manager. SSL certificates are essential to always encrypt the communication to our web applications, so this is also something we need to deploy. And because we need a DNS provider for the SSL certificates to authenticate to our domain and also for the web server in this setup, we also should publish a DNS entry that points to the public IP address of the load balancer to route traffic to this specific domain to the correct application. So I'm using Cloudflare as my main DNS provider in this example, and this also offers an integration with Terraform to create and manage DNS records. So I know this seems like a pretty complex setup, and yeah, it actually is. It took me quite a while to find out how these components all work together, and I've used them manually in some videos before, and now automating this all in Terraform is cool. But I get it, it can be overwhelming and take some time to think through. So don't worry, you will find all the project files that I will use in this video on my boilerplates repository on GitHub. So just follow the link in the video description to my profile, and in the boilerplates repository, navigate to Terraform templates, and there you will find a folder which is called Kubernetes Automation Example. So one more thing before we can get started. To deploy a Kubernetes cluster in this video, we will use my favorite cloud provider Civo, who is also sponsoring this video. I run all my cloud infrastructure on Civo now because they offer you a flexible and fair pricing for Kubernetes, Linux machines and storage, and you can easily manage your resources through their web interface. It's all very intuitive, but they also have many advanced tools and features like CLI tools, APIs and integration with Terraform. So if you want to follow this video along and try out Civo, you can just use their free credits when you sign up. That will give you enough time to check it out. Of course, you will find a link to their website in the description down below. So let's start looking into this project, and first I've started with creating the base file that we need for Terraform. I called it provider.tf here, and I put all the general configuration settings for this project in this Terraform file. So for example, you can set a required version of Terraform and declare the required providers that should be installed for this project. The first provider that I'm using is of course the Civo cloud provider, which will create a new Kubernetes cluster for us. Note that you must use the latest version, or at least the version 1.013, because Civo introduced a few new features in this version which include the management of load balancers. So that's what we require later to get a public IP address to manage our DNS records. In the Civo provider settings, you also need to add the API token which authenticates to your Civo account. So to get this API token, you have to log into the Civo's dashboard and find it in the security settings of your profile. And here you can just copy the API key and specify that in a variable. I always store credentials like this that I require for authentication in a secure store, like variable sets in Terraform Cloud, but that's totally up to you. So remember, just follow the best practices and declare the variables in your project files, but don't store the actual secrets here. So just pass them through with an auto variables file or use something else like Terraform Cloud or HashiCorp Vault. I will probably make a video about Terraform Cloud because that's really nice. But back to the provider settings of Civo. So here you can also specify a data center region to decide where the cloud resources should be generated geographically. So I added the Frankfurt 1 region to put this in the German data center, but you can of course just choose any other region you like. And now that we have done the Civo provider configuration and added the credentials, we can generate the Kubernetes cluster. So first you need to query an instance object that we want for this project, because Civo has different sizes of machines and worker nodes. So this decides how many CPU cores, memory and SSD capacity your Kubernetes worker nodes should have. And you find that out in their CLI tool. If you want to know how to install this CLI tool, you can just follow their official documentation. It's pretty straightforward to install this on Windows or Linux, and then also you need to set an API key to authenticate to the CLI tool. And once you've done this, you can enter the command Civo Kubernetes size to get a list of all the available nodes, and you can see how many CPU, memory and SSD capacity they have. For this short demonstration, I just picked the name of the smallest available machine, and in the object of the Terraform file, I just put this name in a filter with the key name, and that should also match by a regular expression. So this object will then have the identifier of the Civo Kubernetes instance size. And then we can define the Kubernetes object, which I have just called Kubernetes Demo 1, and I defined it with 2 nodes from this smallest size object. So here we need to refer to the element data object we have stored the correct size in. I also want to protect this Kubernetes cluster by adding a new firewall object to it. I always do this to decide which ports should be accessible from which IP addresses or networks, because otherwise there's no additional protection between the public internet and the Kubernetes cluster. So let's add a new Civo firewall object. So here it's important to set the create default rules parameter to false, because otherwise Civo always adds the default rules, and this would allow traffic from all IP addresses on all ports. This is nothing that we want. And then you can create firewall rules for this object, where you define if this should be an ingress or egress rule, and if it's valid for all IP addresses or maybe just for some specific ones. And of course which ports should be open or closed and whether it's allowed or not. So I think there's nothing really special I would need to explain. I think it's pretty straightforward, but just a few tips regarding these firewall rules. So in this project we're going to expose a web application via the load balancer Traefik. So I needed to create 2 objects here. I called them Kubernetes HTTP and Kubernetes HTTPS. And these firewall rule objects that I've created here allow ingress traffic on port 80 and port 443 for all public IP addresses. And I also added a new rule for the Kubernetes API port, so this is needed by the Terraform program to communicate with the cluster, and you also would need that if you want to connect to it via kubectl, for example. So here you could also think about limiting this to your own public IP address where you are located. I would definitely do this. Sure, opening this port to all public IP addresses doesn't really mean anybody could just log into your Kubernetes cluster. You still need, of course, to have a valid certificate and authenticate, but still it might be a security risk if somebody somehow gets your kubeconfig file, or there is a general security vulnerability inside a specific Kubernetes version. So I personally always tend to follow the best practice and never expose any administrative port to the public internet. I always just open what is required and nothing more. Okay, so let's just quickly check what we have so far. We have the providers file, the credentials file, the CVOs file where I have created a new Kubernetes cluster and a firewall. Let's first initialize this Terraform project to download the required providers and initialize the general project. And if you've done everything right, you can then run the Terraform plan command, so that will tell you which resources it would create on this cluster. And if that's okay, we can confirm this with the apply command and wait until our resources are created. And that's it, we now have created a high available Kubernetes cluster with 2 nodes automatically in Terraform. It's nice, but that's just the foundation of our setup, because we now want to deploy some applications on it. And here comes the tricky part, because when we'd like to create any resources on this cluster, we of course need to somehow authenticate to it. Of course, we could now just log into the CVOs dashboard and download the kubeconfig file and place it into the Terraform config somehow, but that would always involve a manual step between the creation of the cluster and the creation of the resources, which isn't really comfortable. And I wanted to find a way that I could run this entire command without any manual interaction. Luckily, there is a way to automate that and retrieve the kubeconfig in Terraform. You can also put this into other providers and use it to authenticate. That's really cool. So let's do this by taking a look at the Traefik example, because I want to deploy the load balancer Traefik on this Kubernetes cluster, and I'd like to customize a few things during the deployment. So in the past, I've always used the Helm package manager to install this manually, and if you don't know Helm, you should definitely check this out, because otherwise this step might be a bit hard to follow. In the Terraform registry, you can take a look how Helm can be automated with Terraform. So you can use that to deploy software packages in Kubernetes, but that needs to be configured with proper credentials, of course. So first I added the Helm provider as a required provider in the Terraform providers file, and then I configured the general settings and the credentials for it. To authenticate to Kubernetes, we now have 3 different options according to the Helm provider's documentation: using a kubeconfig file, using credentials, or using exec plugins, which don't really work in this case. And as I said, we don't have any of these credentials yet because we haven't downloaded them from the cluster. But what we can do now is we can retrieve these credentials from the Kubernetes object in Terraform. And that took me quite some time to figure out how it works. So you need to add 4 different variables to authenticate to the Kubernetes cluster: the host, which is the URL of the Kubernetes API, the client certificate, the client key, and the cluster CA certificate. And all this information can be accessed by using the kubeconfig attribute of your Terraform clusters object. Now you still have the problem that this kubeconfig is still a text file. It's not a single parameter. So what we need to do is we need to use the YAML decode function of Terraform, which decodes this text file into single arrays. And then we can iterate through them and just reference the correct attributes. And what's also important is that you decode the certificate and the key strings with a base 64 decoder. That's also working with native Terraform functions. If you ask me, that's really outstanding. I've used the same technique for other providers as well, like the Kubernetes provider and the kubectl provider, which will allow me to create resources and manifest files on this cluster. And again, please excuse me if I jump over a few things a bit quicker, because if I would explain all of this project in the same detail, this video would be an hour long, and I feel it would be better to not impose that upon you. So let's continue with the provider settings. So I added the Kubernetes provider and the kubectl provider in the same way as the Helm provider. I will later show you why we need all these different providers. And then I added a new file for Traefik. So in this file, I first created a new namespace for it because I don't like to deploy this in the default one. And the next resource is a Helm release, which will use the Helm provider of Terraform and deploy a Traefik Helm chart from the official repository in that namespace. Here it is also vital to add a depends on, because I found out that Terraform sometimes tries to deploy Helm charts or manifests, although the reference namespace isn't created yet, and then the deployment will fail. So with this dependency, you can tell it to only create this object after the dependent object has been created. And in the Helm release object for Traefik, you should also set some general parameters. For example, I think it's pretty useful to set it as your default ingress class, because then we don't need to specify any annotations for Traefik in our ingress objects later. But technically that's totally up to you, so just configure Traefik as you need on your Kubernetes cluster. And I also like to redirect any HTTP traffic automatically to HTTPS, because HTTP should be never used unless you have a very specific use case. That's always a good practice in my opinion. Okay, so that is everything we need for Traefik. It's very simple because we are just using the Helm charts to do all the work for us. And let's now continue with the Cert-Manager, which will manage the SSL certificates. So I also added another file which is called Cert-Manager, and this deploys another Helm release to manage my SSL certificates, and it should also install the custom role definitions. That's really important. I've explained both Traefik and the Cert-Manager already in separate videos, so I'm not going to do that again. But one thing I should mention here, because you might have noticed these time sleep objects that I've placed in the Cert-Manager, the Traefik, and also the Kubernetes cluster file here. And they are pretty important because without them, sometimes the deployment of Terraform objects will fail, even when everything in the file is correct. The problem that I had once I run this entire Terraform project is that sometimes the resources can't be created because the Kubernetes cluster didn't create the dependent objects fast enough. Because let's say you create a new Kubernetes cluster and you want to create a new SSL certificate object of Cert-Manager on it. Terraform knows that it can only create the SSL certificate after the Kubernetes cluster has been created, but you still likely will run in an error because the issuer object for this SSL certificate hasn't been created yet, and that can take a few seconds. And you somehow have to tell Terraform it's not enough to add a dependency, you also must wait a short time between creating one resource and another resource. Because sometimes there are some background tasks running that aren't finished immediately. I know this is sometimes a bit confusing, and I needed to go through a lot of trial and error, destroy the cluster, create it again to see at which point it was failing and where I needed to add a specific timer. But I think it's the only way to do it. So whenever you see these timers, you know they are important for some objects to wait until some background tasks are finished. Whoa, this video is already pretty long, so we haven't gone through the half of the stuff that I wanted to show you. So yeah, it might become a longer one again, but I hope you still have fun and it's still interesting. Let's briefly summarize what we have so far. So we have our Kubernetes cluster with a firewall that's already up and running. We have Traefik, which is our load balancer. We have Cert-Manager to manage the SSL certificates on the cluster. I applied all the necessary changes to this Kubernetes cluster and checked that Terraform created these resources successfully. So know that the base system of our Kubernetes cluster is deployed successfully. We have Traefik, we have Cert-Manager. We could now already open a web connection to it because we have a running load balancer. So here now comes another interesting part, because our load balancer gets a public IP address that we need to use to access any applications on the cluster. And we also need to know this public IP address to use it in our DNS records. When you log into the Civus dashboard, there is now a new section which is called load balancers, and this is a new feature that has been recently rolled out because load balancers will now cost an additional $10 per month once you have them running in your cluster. So once you deploy an application like Traefik on it, you see there is a new load balancer object created here, and you can then just copy this public IP address. But of course, we won't avoid doing this manually. Instead, let's create another Terraform resource from the type Civu load balancer. And I will call this Traefik_LB, which depends on the Helm release Traefik, of course. And here you just need to paste the name of this load balancer object. And then you can use this load balancer object in Terraform, and you can just refer to its public IP address later in other objects. So that's also pretty cool. But first, I added a new provider to manage DNS records with Cloudflare. Of course, you don't need to use Cloudflare. Most DNS providers have their own integrations with Terraform, just like I said in the beginning, but Cloudflare is pretty good in my opinion. And here you also need to add an API token, of course, so I created two variables, one for my mail address and another one for the API key. It's worth noting that you can also use an API token in Cloudflare, that's up to you. You will find them in the Cloudflare dashboard under your profile, and then in the left menu just select API tokens. Just create a new token or use a global API key, again, it's up to you. And now we can configure Cloudflare in Terraform. So remember, we need Cloudflare for two things. First, for the DNS record itself, so that we need to create a new A record that routes traffic to the public IP of the load balancer, but also for valid SSL certificates, because we're using a DNS challenge here. So that's why I created a new secret object in a new file, which I've just called Cloudflare. And here I will put the API key into a new object, which I store in the Cert-Manager's namespace. So this is needed because we obtain a new SSL certificate. I want to use a DNS challenge that verifies the ownership of my domain using the Cloudflare API key. So I've talked about this in my Cert-Manager tutorial on Kubernetes already, so if that's a bit fast for you, you can just check out this video. Here I'm just using Terraform to automate this certificate generation process. So let's now come to this part. First, we require a new cluster issuer object, which is responsible for obtaining and managing these SSL certificates. And the main problem I had with creating this resource is that this is not a common Kubernetes object, because Cert-Manager has its own resource types for managing issuers and certificates. It's not existing in the Kubernetes Terraform provider. But there's also a pretty nice workaround for this, because Terraform has also another provider which is called kubectl, and this provider can deploy any YAML manifest file. It's not depending on any object type, so I will show you. That's pretty easy. You can just create a new resource from the type kubectl manifest, give it a name, and then just paste in your regular manifest file that you would want to deploy on the cluster. So that's nice, because you can just use any manifest file that you have used elsewhere. Very straightforward. And here I've just created a new manifest to deploy a cluster issuer object, which is called Cloudflare prod. So this will create a new certificate issuer in Cert-Manager and use our Cloudflare API key secret. So with this object, I later can issue new certificates that are signed by Let's Encrypt. And this will be valid for all domains that I'm managing in Cloudflare. So now here it's also essential to add a sleep timer after creating this issuer, and also add a dependency on Cert-Manager, because this object needs to be created a few seconds after the Cert-Manager deployment, and any certificates that should be issued by this object should also be delayed. So this is why the sleep timers are so important in Terraform. Now I have deployed these resources, and I think that's all we need. We have a load balancer, we now have a certificate issuer, we have prepared everything else that we need. Yeah, that was a lot of stuff, but now we are ready to deploy any kind of web application on this cluster and expose it securely. Let's now find out how that works. I think it's best to make it simple and just run an Nginx web server to demonstrate that. Of course, you can apply the same pattern to any other application you want to automate on this cluster as well. So first we need the application deployment, so I created a new namespace which I've just called Nginx1, and a new deployment which makes sure that always one replica pod is always running on the cluster. I defined the details of this container to run it with an Nginx image, and expose this web application on the container's port 80. Nothing special here, you should already know that. What we also need for this is, of course, a service object from the type cluster IP, so this means it's only accessible from inside the cluster, but that's okay, because we want to expose this service object via Traefik later. But to expose this service securely, we of course first need an SSL certificate. So to create this certificate, we need to create a new kubectl manifest resource, again, very similar to the cluster issuer object. So I just created a new resource called Nginx1 certificate, and that depends on two objects, the namespace Nginx1, because that's where the certificate needs to be created in, and it also depends on the cluster issuer sleep timer. The sleep timer here is needed because we want to create this certificate a few seconds after the issuer object has been created. So we must wait a little bit. And here I just paste my existing certificate template that I've already used in other videos and projects. So I just changed the names to Nginx1, and I also added a DNS name nginx1.clcreative.de, and this will get a new valid SSL certificate for this domain by using the cluster issuer Cloudflare prod that I've just created before. And once we have this certificate, we of course need to create an ingress object for Traefik to expose this application on the DNS name. So here I can just use the Kubernetes provider again to deploy a new ingress resource that also should depend on the Nginx1 namespace. And that will route all paths to the backend service object Nginx1 on the container port 80. So this ingress object will route the traffic to the application, and it will use the certificate that we have created and stored in a secret object. So just specify this certificate in the TLS parameter and refer to the Nginx1 secret object and put the correct DNS name in here. And then we only need one more thing. We need a DNS record in Cloudflare that routes this DNS entry to the public IP of the load balancers object. And because we already have created this load balancer, I can create a new object from the resource type Cloudflare record, set the zone ID for my top level domain CL creative.de, and just put in the DNS record. And as a value for the public IP address, I can now refer to the load balancers resource Traefik_LB that we have created and the public IP address attribute. So that should be all. I know it's a lot of stuff, so let's summarize this once more. We have the namespace and the application deployment, the service object, the certificate, the ingress object, and a DNS name. And when I deploy all of this stuff, that of course will take some time. And after this is complete, I should be able to just open a web browser anywhere and enter this DNS name in the address bar, and that's it. This is our test application that we have deployed on Kubernetes, and we have configured everything that's needed. We have a valid SSL certificate for our website by using Traefik and Cert-Manager without doing anything manually in any web interface, by just using code and this fantastic tool Terraform. So I'm really excited about this. I hope this gave you some ideas on how to automate your cloud infrastructure and Kubernetes resources with Terraform. This is actually the reason for me why cloud native is such a big thing in IT, because you can create even complex setups and environments all through code and automation stuff without doing anything manually, and you can just store this project in Git, and whenever you need something new in your environment, you can just add a new resource to this Terraform template, and when you have a working setup like this, you can just easily replicate this into multiple stages. So you can create a Kubernetes cluster for testing, one for staging, one for production, whatever you need. So next we will also take a look on how Terraform can be used in local environments, of course. So this is really a cool project that I've done with Terraform and Proxmox in my home lab, so stay tuned for that. And if you enjoy videos like this, then don't forget to like and subscribe. That's always helping out the channel. And of course, thanks everybody for watching. I will catch you in the next video. Take care. Bye bye.